This video is to kind of review fundamental counting principle and factorials. So we're going to start with number 1 here. We have a restaurant that offers 4 sizes of pizza, 2 types of crust, and 8 toppings. So we could draw a tree. It said it had 4 sizes, so this is example 1. 4 sizes of pizza. It had 2 types of crust and 8 toppings. If we were to draw a tree, it would be ginormous. So we would have 4 sizes, so maybe small, medium, large, extra large. And then we'd have 2 types of crust, so maybe thin and thick, or maybe we'll call it pan. There we go. Thin or pan, thin or pan, thin or pan. So I could have a small pan crust. I could have a medium thick crust. So I have all those different possibilities. Now I have 8 toppings. So on each one I would need 1, 2, 3, 4, 5, 6, 7, 8. And I would need to do that on every single one. So it's going to get very large very quickly. Or I can use the fundamental counting principle. So the way I think about this is I have how many sizes of pizza? I've got 4. And I have 2 types of crust times 2, because this would give me a total of 8 possibilities, times 8 toppings. So 4 times 2 times 8 is 64 possible combinations. Okay, so now let's look at a different one. Let's look at something like number 7. How many 5-digit numbers can be formed if each one uses all of the digits, 0, 1, 2, 3, and 4, without repetition? Now, we are going to make an assumption that if it's a 5-digit number, 0 can't be the first number, because then it would be a 4-digit number. So we need to think about, this is number 7. So I have the first digit, second digit, third, fourth, and fifth. So this is the first number, the second number, the third number, and so on. So if it can't be a 5, or it can't be a 0, I have 4 possibilities for the first number. Now, say the first number was a 1. Now how many possibilities? Because it says without repetition, meaning I can't have a 1, 1. So that means I have a total of 4 possibilities, 4 possibilities again, because I can't have that repetition. So let's say it was a 1 and then a 0. Well, I've used 2 of the numbers, so I have 3 numbers left. Now I've used another number, so I have 2 numbers left, and I've used another number, so I have 1 number left. So I would just multiply those together. So 12 times 8, 12 times 8 would give me 96 possible combinations. So when you do this assignment, I do want to see what each one, I want you to have a little line and what each one of them equal. The next piece is the factorial. Factorial is just an easy way to write like this. This would be 4 factorial. So factorials. So 5 factorial is equal to 5 times 4 times 3 times 2 times 1. So sometimes we have to solve problems that look like this. 25 factorial, this is number 13, over 20 factorial. Now, typing that all in your calculator takes forever. I will show you a shortcut. However, I want you to think about what that means. This means 25 times 24 times 23 times 22 times 21 times 20, 19, 18, 17, and I could keep going on. And then it's all being divided by 20, 19, 18, 17, and it will go on to 1. So this is a division problem, so I can cancel. And so I'm left with what I get when I multiply those. Now, if you are putting it in your calculator, numbers like this are way too big for a calculator to handle. So, but I'll show you how to do it anyhow. So if I hit math, well, first I'm going to do, let's do 6, and then I'm going to hit math and go over to PRB for probability. I'm going to go down to the exclamation point. 6 factorial is 720. 6 times 5 is 30. Times 4 is 120. Times 3 is 360. Times 2 is 720. So 720. You can also do things, let's try this one. I don't think it will handle it, but let's try it anyway. So math, PRB, go down to exclamation point, divided by 20, math, PRB, oops, math, PRB, I forgot to go down to exclamation point. Oh, it did do it for us. So it looks like we'd end up with 6,375,600. Okay. And that pretty much covers fundamental counting principle and factorials.